Hey, ladies and gentlemen, welcome to lesson 3-4. This one's all about direct variation. You learned about direct variation as a 7th grader, so let's try a 8th grade take on this one. So direct variation is any specific equation where it falls into the form y equals kx. This is super duper important. And k cannot equal to 0, cannot be equal to 0. So here I have that super duper important formula. There's some really important parts about this as well. The key points are is that k is always going to be something called the constant of variation. So we're going to put that in there, the constant. Oh my computer's super slow right now. So the constant of variation, and this stuff's all in your book too. It will always go through 0, 0, because 0, 0 is a solution. 0, 0 is called the origin. And 0 will be your x and y intercepts, which means that we know it's always going to go through the origin. So other ways that I could have written this, it's the constant of proportionality. It's also called slope. And we'll show all of that stuff in a little bit. So check it out over here. These are just examples of direct variation graphs. These are all examples of direct variation because they go through 0, 0, and they are a straight line. So that's the most important thing for us when we're looking at a graph and saying, is it direct variation or is it not? It must go through 0, 0. On this next example, remember that a direct variation equation is in the form of y equals kx. K is the constant of variation. Slope, which is also signified by an m, is also the same thing as k. Because if we were to go up 1, 2 for my rise, to the right 2, to the right 1, so it'd be 2 over 1 for my rise over 1, my slope is 2. The number in front of the x is my k, so my k is 2. And we find out that m is also a 2 due to that y2 minus y1 over x2 minus x1 stuff. All of these things mean the exact same thing. We're talking about slope, constant of variation, and k, all meaning the same thing. It's how steep a line it goes up the line. In example A here, our job is to determine if this is a direct variation situation. So you want to order pizzas. Each pizza will cost you $7, but you have to pay a $2.50 delivery fee. So let's make an equation. So y would be the total cost. It costs you $7 per pizza, so if P stands for the number of pizzas, plus a $2.50 delivery charge. Now, as a guy who used to deliver pizzas, that's a pretty good gig. Maybe you want to think about doing that instead of going to the football game on Friday nights. It's a bad idea anyway. All right, so because you can see that this does not fall into the same category as y equals kx, this is a big fat no. It's not a direct variation equation. In example B, you are a babysitter. You earn $8 per hour. So if y is how much money I make, $8 per hour, if x is the number of hours, folks, that falls directly into direct variation equation. And then an example C. You and 6 friends go to Valley Fair. It costs $30 for each person to get in and $10 to the park. So 6 friends. So there's 7 people, right? So it's going to be $30 times those 7 people, or times P, plus $10 to park. So this would be the total cost. And does this look like a direct variation equation to you? Does it fall into the y equals kx? The answer is no, it does not. If we got rid of this, it'd be okay, but we don't have that there, or that is there, so it makes it a no. All right, here's our next 2 examples. The last 2 examples, they are probably the ones that are the most confusing. All right, so our job is to take the information, suppose that y varies directly as x. So that's always going to be in our words. We're going to take the y and the x equals, and we're going to plug them into the y equals kx for part A. So this is going to turn into us saying 9 is equal to, if my computer can keep up with me, here we go. I think it's back. No, it's not back yet. 9 is equal to a k times -3. So our job is to solve for k. So we're going to divide by a -3, divide by a -3, and we find out that k is equal to a -3. So if I have k is equal to a -3, then you will see here, folks, that if I plug it back into the original equation, it'll say y is equal to a -3x. Now the next part of the problem is to write a use the direct variation equation to find x when y is 15. So we're going to use y equals a -3x, and we're going to plug in y equals 15 into that equation. So this is part B. So it's going to say 15 is equal to a -3 times x. So to solve this, we're going to divide by a -3 on both sides, just like we have been doing for the last 2 chapters. And we find out that x is equal to a -5. And that, my folks, my friends, my students, my homies, this is answering part A and part B. I'm going to ask you to do this question on your own and see if you can do it correctly. On Friday, when we check this work, we'll check what you got for an answer. All right, folks, this is the Bermanation signing off. Good luck.